Hello everyone, welcome back to another video. My name is Dylan and you've clicked on this video because you want to see yet more reasoning problems with maths to prepare yourself for any questions that might appear. This is the entire 2019 paper 3 reasoning. Paper 3 reasoning are traditionally a bit trickier. Let's take a look, shall we, and solve every single question on this paper. Guys, before I get going, can you please like this video, subscribe to our channel? We've got way more on the way, and share this video to as many people as possible. We appreciate you guys coming back time after time. Let's dive straight in to question 1. The original price of this car is £8,999. There is a sale with £1,100 off. What is the sale price of the car? We simply have to take off £1,100. Let me remember to put in my 100. That'd be pretty good, wouldn't it? So we know we're going to keep the 99 at the end because we're not going to change any of that. And we have to take off 1,100. So it's going to be 7,800. So that's going to give us 7,899. If we wanted to check this answer at the end, we'd add 1,100 back on. And we should get 8,999, which we do. And that's the answer to that first question there. Which digit is in the 10,000s place? This is basic place value. We have ones, we have tens, we have hundreds, and then this kind of repeats itself, but this time with thousands, and then we have 10,000s. Oh, it's a bit cramped up there, but this is 10,000s right there. 7 10,000s. Listen, don't get tricked. Don't write down 70,000. It doesn't ask you what's the 7 worth. It says what digit, which digit. The digit is 7. Simple as that. Round 3,576,219 to the nearest million. So to do that, we look at the millions. We're on 3 millions, which means our answer is either going to be 3 million or the next million, which is 4 million. How do we know whether to round up or down? Well, we look at the next digit here in the 100,000s place. It's 5. That's halfway. So we're going to round up to the next million. Therefore, the answer to this question is 4 million. Be really careful when you put your answer in that you have the exact right amount of place value holders. For million, we have 6 place value holders, 4 and then 6 zeros. That gives us 4 million. That's the answer to that question. Next up, Dev. I had £10. I gave some money away. Quite simple. Which expression shows how much money Dev is left with? This is algebra. We're going to put something someone has said into an algebraic equation. A is the amount of money in pounds that Dev gave away. So we started with 10. And he gave money away. And what we have to do here is understand, well, what is the action of giving money away if I was to write it as an operation, addition, subtraction, division, etc. But we're not adding on the amount of money he gave away. How can you give money away and end up with more money yourself? That doesn't make any sense. 10 divided by A. Again, A is how much money he gave away, not who he shared his money with. It's not division, so it can't be this one. A, take away 10. No, this would mean he started with A and gave away 10. A is what he gave away, so this is the wrong way around. 10 take away A, that is the answer. We can double check A times 10. We're not multiplying, we're not getting more money. He gave money away, we must be getting smaller. So no, that would not make any sense. Question 4. Oh, let me get this nice on the page, shall we? There we go. Write these masses in order. Mass is linked to weight. You might think, what's masses? It's just how much something weighs, but mass is the correct mathematical term. Starting with the lightest, so we need the smallest amount. Now, straight away, notice this. 1, 2 decimal places. 1, 2 decimal places. By the way, decimal place is how many digits are written after the decimal. Here we have 3. This could prove to be a bit tricky. So my advice is to just change the first 2 into 3 decimal places by putting a placeholder at the end. By putting a placeholder at the end, we do not change the value, but we do make sure it's easier to then compare. So what's the lightest one here? Well, look at the ones column first. We have 1, 0, 1, 0. So the lightest 2 are these 2 here with zeros. Okay, well, what's the lightest out of those 2? 0.9 something, 0.0 something. Clearly, 0.0 something is going to be lighter. Again, just make sure when you put your numbers in, you copy them exactly. 0.009, done. Then the next lightest obviously must be this other one that starts with a 0 in the ones column. So it's 0.99. I am again not going to put my placeholder in here because that was just to help me with the question. I don't need to do that in the answer. I put 0.99. Now I'm left between 1.25 or 1.025. Okay, well, what's the smallest one? Because we're going from lightest to heaviest. It's going to be the 0 here because this is 1.2. This is 1.0. So clearly 0 is lighter. So again, I write this whole number in here, 1.025. And then the last one remaining obviously must be the heaviest, which is 1.25 kilograms. Just be systematic. Those questions are quite easy. Write the missing digits to make this addition correct. This, at the minute, it looks a bit tricky. What I would always do is write this out and make your own column method. So we have blank to blank plus, and let's line these up now so it's much easier to work out, blank 2, so 10s and 1s. So this blank actually goes underneath the 2, and we have a 2 here. And in total, we're given the entire answer, which is 2 in the hundreds and then placeholders in the 10s and the 1s. Now this is much easier to work out. Something plus 2 equals 0. You should straight away be thinking, that makes no sense. No, because we're not trying to make 0. We're trying to make a number that ends in 0. So we're trying to make 10. So put in that exchange because this is going to be helpful later. Can you think of a number we can add to 2 to make 10? I can. It's going to be 8. 8 plus 2 is 10. Now be really careful again because we've got 2 plus something plus 1 equals 0. Well, we know it's not 0. We're actually going to be making 10. That's why this question is tricky. You need to realize we're making 10. 2 plus 1 down the bottom here is 3. What do I have left to get to 10? Well, 3 plus 7 is 10. Now I can prove here 7 plus 2 plus 1 is 10. And again, I've got 1 at the bottom plus blank is going to give me 2. So this must be a 1. So this is 72 plus 128. Now, if we hadn't done this right here, we might have rushed in and just gone, well, in the hundreds must be 2 because there's 2 hundreds. And you'd be wrong straight away. So what I would do for these questions is always just put them into column method and work like that. And usually when we've got missing digits, it's relying on you knowing that sometimes we have to put some exchanging in. That's not written down, but would be in our working out. Well done if you managed to get that one. Question 6, John buys 1 toy car and 1 pack of stickers. Toy car is 149, stickers are 164. He pays with a £10 note. How much change does John get? Look, we've got a box saying show your method and 2 marks. We know we have to do at least 2 things. And to even get 1 mark, we have to do 2 things. I just split the box in half. That's my method. I might do a video on 2 mark questions and the best way to get 2 marks every time. So here we have £1.49 and £1.64. The first thing is, okay, well, actually, how much is that altogether? Because we need to figure out when John went to the till, what did the cashier say? That'll be blank, 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 please. So the first step is to just work out the total. 9 plus 4 is 13. 6 plus 4 is 10, plus 1 is 11. Put your decimal place in. 111 is just 3. So we have £3.13. If you stopped there, you might get 1 mark. No, you might not. You'd get 0. Remember, to get 1 mark, you have to do a full double method and just make a maths mistake. So the next part is then to find out the difference between £3.13 and £10, which he gives the cashier. So to do that, we write down £10. And again, £3.13, to line it up correctly, the 3 would go in the 1s, and then we'd have to do a decimal. So to make sure our number looks good, this looks a bit crazy at the minute, you can change £10 into 10.00. Put placeholders in with money, that's no problem. And now we're going to subtract, because if I only owe £3.13, or John in this case, he wants his money back, the difference up to £10. 0 take away 3 you cannot do. Do not fall into the trap of putting 0. We're going to do a long exchange here all the way over. So this 1, we cannot just put it in the ones column. That does not work like that. This 1 we exchange here. Now I've got 10. I can take 1 out, leave 9, and exchange to the next column. Now I can exchange, take 1 out, leaves 9, put 1 in the ones column. 10 take away 3 is 7, 9 take away 1 is 8. Decimal place goes in, don't forget that. 9 take away 3 is 6, and we have nothing here in the tens, so the answer is £6.87 change. That's how you get 2 marks. Question 7, this picture shows the masses of 8 kittens. We talked about mass earlier, it's just like the weight, simple as that. What is the difference in mass between the heaviest kitten and the lightest kitten? So a couple of things we have to do here for 1 mark. Find the heaviest kitten. 300, 300, 300, 200, 200, 400. This is the heaviest kitten. It's the only kitten in the 400, so it must be the heaviest. And I heard some 200s here, so the lightest is going to be 200 and something. 275 maybe? No, 255. Always check all of the numbers before diving straight in. The difference means we're going to subtract. 0 take away 5 we can't do some exchanging. 10 take away 5 is 5. Going to put 5 in the 1 straight away here. 0 take away 5 again, we cannot actually do that yet until we exchange. We can do, I always say, we can go into negative numbers but not with column method. 10 take away 5 is 5. 3 take away 2 is 1. We have 155 as the difference, but I don't think this question's over yet. No, it's not. Write the missing numbers in the table. 1 has been done for you. we've put them into 4 groups, is what it says up here. How many kittens were 250 to 299? 1, 2. Just 2 kittens. So I'm going to put 2 there. How many kittens were 300 to 349? Yes, 1. No, 2. 3. 3 kittens. Okay. How many kittens were 350 to 399? 1. Ooh, 2. Okay, looks like that's it. And then we've got 1 at the end. Let's make sure these add up. 2 plus 3 is 5, plus 2 is 7, plus 1 is 8. Should be 8 kittens altogether? Yes, there is, because the 400 was already done for us. Question 8. Let me get these questions lined up. Always goes wrong. Here we go. Ken is playing a game. He has 4,289 points. Then he scores another 355 points. Showing off now. Ken's target is 6,000 points. How many more points does Ken need to reach his target? This type of question comes up all the time, where you have a total amount. In this case, the total amount is actually 6,000 because that's his aim. And then you're given 2 parts to it. So he's already got 4,289, which is a big chunk. So let's write 4,289. And then he gets another chunk towards his target, which is only a small little 355. And the question is basically saying, okay, how much more does he need to get to his target? That's this little gap here. And this comes up all the time in the SATs. A total amount with 3 parts. You're given 2. What's the missing part? Show your method, 2-mark question. First job, let's figure out how much he actually got altogether when he got his 355 and his 4,289. So first thing is to add these up. 4,289 plus 355. That'll tell us what score Ken is on right now after he scored his second lot of points. That's 14. 8 plus 5 plus 1 is 14 again. 3 plus 2 is 5 plus 1 is 6, and the 4 comes down. So Ken is currently on 4644. So we know that this is 4644. So to figure out how much more he needs, we're going to have to take the total, in this case 6,000, and we're going to have to do subtract 4644. Cool. Now we're going to do the same as last time here. We have to exchange for the 6,000s and do 1 at a time. So we can go from 6 is now 5. Now we have 10 hundreds. Again, make that 9 hundreds because now we have 10 tens. Make that 9 tens because now we have 10 ones. Now we can do subtraction. 10 take away 4 is 6. 9 take away 4 is 5. 9 take away 6 is 3. 5 take away 4 is 1. He needs 1,356 more points to get to 6,000. 2-part question. I split it in half normally, just like that, so I know I've got to do 2 things. That helps me. Whatever helps you. But you've got to do 2 things to get the answer there. Question 9. The pictogram shows the number of satellites above Earth in 2016. 2016 number of satellites. And this key is key. This key is key. It tells us what each symbol is worth. How many satellites were there? Well, each circle is 1,000. So that's 1,000, 1,000. So that's 2,000 for the 2 circles. And then we've got this. And this question actually turns into a fraction question. What fraction of a full circle is this? Well, we can draw this, right, to help us. Really crudely, badly drawn. But you can see there, 4 of these would make a whole circle. So we've actually got a quarter of 1,000. A quarter of 1,000 is 250. So we have 1,000, 2,000, and 250. The answer is 2,250. How did I know straight away it was 250? Well, I know that a quarter of 100 is 25. 2 quarters is 50. 3 quarters 75. You need to know these facts. So if it's out of 1,000 instead, it's 10 times bigger, which got me 250. Question 10. On the grid, there are 3 points joined by 2 lines. 1, 2, 3 points and 2 lines between them. Lara plots another point at -1, 2. She joins the points to make a quadrilateral. Complete Lara's quadrilateral on the grid. So we need to plot -1, 2. We start in the center here, the origin, at 0, 0. And we're going to go -1, 2. So -1, firstly, we go across the x-axis. -1, and then 2 up, 1, 2. It's going to be right here. Something to remember with coordinates. We go along the x-axis first, along the corridor, then we go up the stairs. Okay. You can play Xbox before you have your yogurt. X-axis before y-axis. Simple as that. So we've done the first one. No, we haven't, because it says use a ruler, complete the quadrilateral. So you'd be using a ruler right now to join these lines. Remember, guys, look, I'm using a mouse. This is pretty good for a mouse, I must say. So, and then this straight line goes across. Perfect. Question finished, right? Wrong. Look, that'll get you 1 mark. Here's the next part of the question. Then Lara translates, which means moves the quadrilateral 4 squares to the right. Draw the quadrilateral in its new position on the grid. To translate a shape, you go to each corner, and we're going to move it 4. 1, 2, 3, 4. This one would move here. This corner, 1, 2, 3, 4 would go right there. This corner, 1, 2, 3, 4 would go here. And this corner that we just put in, minus 1, 2, 1, 2, 3, 4 would go right there. Then using a ruler, more neat than me, you're going to be joining up these parts. That's not bad for a mouse. Look, that's a mouse. That's not bad. And then we get another mark there. Be really careful when you translate. Go to the corners is the best way to do it. Plot the corners, then you can make your new shape. Here are 5 numbers, 2, 3, 4, 5, and 6. Write each number on the correct cards below. The number 2 has been written. Now, what this tells me straight away is that a number can go on more than one card. So is it a prime number? Goes on that card. Factor of 12, factor of 15. Factors of a number are numbers that go exactly into it. So 2 goes exactly into 12 because it goes 6 times. 2 times 6 is 12. So let's do 3. Is 3 a prime number? Yes, because a prime number has 2 factors. 3 has the factors 1 and 3. Factors are numbers that we multiply together to get the product. So 1 times 3 is 3. There are no other numbers that are factors of 3, so it's prime. Is 3 a factor of 12? Yes, because 3 times 4 is 12. Is 3 a factor of 15? Yes, because 3 times 5 is 12. 3 goes on all the cards. We're done with 3. Number 4, is that a prime number? No, it's not, because it has 1 and 4, but it also has 2. It's in the 2 times table. So that has more than 2 factors. It's not prime. Is it a factor of 12? Yes, like I said earlier, 3 times 4 is 12. Is it a factor of 15? No, 15 is not in the 4 times table. We've done 4. Is 5 a prime number? Yes, it is. 5 has 1 times 5, and there's no other numbers that multiply to make 5, so that means it's prime. Is 5 a factor of 12? No, 12 is not in the 5 times table. However, 15 is in the 5 times table, 3 times 5. We've done 5, just 6 left now. Is 6 prime? No, we've got 1 times 6, but we've also got 3 multiplied by 2. It has 4 factors, it's not prime. Is 6 a factor of 12? Yes, because 6 times 2 is 12. Is 6 a factor of 15? No, 15 is not in the 6 times table. Be systematic, should be an easy question to get right. Question 12, Amina's bed is 190 centimeters in length and 91 centimeters in width. She's making a 1/10 model. This means if it's a scale model, we simply divide by 10 because 1/10 is 10 times smaller. If something was 1 meter long, the scale model would be 10 centimeters. We have to divide by 10. So to do that, this question is basically asking us to take the length, 190 centimeters for the real bed. On Amina's model, we do 190 divided by 10, which would get us 19 centimeters. So the length is 19 centimeters. And the width in the real bed, it was 91. Well, we need to divide that by 10. 91 divided by 10, we're going to shift it past the decimal place, and we're going to end up with 9.1. So we're going to have 9.1 centimeters as the width. That's what Amina would have built. So that's what a scale model means. We're scaling up or down by multiplying or dividing. In this case, it's 1/10, so we divide by 10. Question 13. When you double the size of an acute angle, you always get an obtuse angle. This is testing, do you know what these vocab words mean, first and foremost? Acute angle is 0 degrees to 90 degrees, not including 90. Okay, 90 is a right angle, so 89.9999999. An obtuse angle is anything from 91, let's say then, up to 179. Okay, so let's just change this to 89 for argument's sake. Okay, because 90 is a right angle, doesn't count as obtuse or acute. Explain why Kirsty is not correct. So we're told Kirsty is not correct. It's not part of the answer to say, Kirsty is wrong. That will not get you a mark. What will get you a mark here is proof that she's wrong. So let's take an acute angle. So acute plus acute. To prove this, we need to make this equal not an obtuse angle. We need to make it equal an acute angle again. And we can do this by proving it. 20 degrees is an acute angle. We're going to double it. So 20 degrees plus 20 degrees is 40 degrees. All of these are less than 90. So we can say less than 90, so not obtuse. And that is enough to get the mark. You've proven it. Really good sometimes to prove it using maths. That's a really good way to prove it. You've explained it because you did the maths and then you said, well, all of these are less than 90, so it's not obtuse. Put as much detail in as possible. I've done a whole video on answering these reasoning questions. Go and have a look if you still think it's something you're a bit stuck on. Question 14. How many days are there in September, October, and November altogether? Loads of ways to remember the days in the months of the year. I do the song. 30 days have September, April, June, and November. So these have 30. All the rest have 31, apart from February. But I know October has 31 because Halloween is on the 31st. So it has to have 31. So there are 91 days in September, October, and November altogether. We just have to add them up. Question 15. The International Space... That is a tongue twister for me. The International Space Station, my goodness, orbits the Earth at a height of 250 miles. What is the height in kilometers? And look, we're given the conversion. 8 kilometers equals 5 miles. Okay, let's move this down then. So 250 miles is how many kilometers? Well, 5 miles is 8 kilometers. It's good to know. So what's 25 miles? Well, to get from 5 to 25, we multiplied by 5. Do the same here to kilometers. Multiply this by 5 to maintain equivalence. That means 25 miles is 40 kilometers. Cool. Well, now we need to move from 25 to 250. Hopefully you see that's really easy. We just times it by 10. So do the same here to maintain equivalence. Times 40 by 10. And we end up with 400 kilometers. So all we're doing here again is just scaling up that ratio. 5 to 8, 25 to 40, 250 to 400. Using the same multiplication on either side. That's how to answer these questions. 400 is the answer. Question 16. Jack buys 1.5 kilograms of potatoes and half kilogram of carrots. How much change does he get from £5? Again, first job, work out how much the potatoes and the carrots cost. So £1.50 per kilogram for potatoes. He buys 1.5 kilograms. So he's going to buy £1.50, which is 1 kilogram. And we're going to add on half of that £1.50, which is 75p. This will take us to 1.5 kilograms, which I can work out here is £2.25. So Jack spent £2.25 on potatoes. Carrots, half a kilogram. They're £1.80 per kilogram. So we're going to do 180 divided by 2. And you can use your times tables facts for this. 18 divided by 2 is 9. So that's going to be 90 pence. Cool. Now we need to find out the total. So we've done two things already. We're going to do £2.25 plus 90p. That's going to get us to £3.15. Again, you can do all the working out really carefully, but I can see it's £3.15. And that's the answer, right? No, it is not. To get 2 marks, we're going to have to get the correct answer and show a full method for even 1 mark. How much change does it get from £5? Well, now we need to do £3.15. Now, I could sit here and do £5, take away £3.15 again, do exchanging, but I've shown you that already. So I'm going to show you a different way. £3.15 down the bottom. And to find the difference or the change from £5, we can use a number line and just jump forward. So £3.15, we can do an 85p jump. Gets us to £4. And then we can do a £1 jump. Gets us to £5. So what are the two jumps worth altogether? 85p plus £1. That's £1, 85 pence. That's his change. Multiple steps there, more than 2 steps. So it doesn't always work just to do 2 steps, but we're still going to get 2 marks because basically if you have this answer written down, you get 2 marks. It's as simple as that. Question 17. X plus 2y equals 20. X and y are whole numbers less than 10. What could X and Y be? A good method here, trial and improvement. Put a number in. What's a number less than 10 that we can put into Y? Well, let's put in 8. I don't know. Let's try it. So imagine Y is 8. So 2y, 2 times 8. That's going to get me 16. I need to make 20. So what would X be? X would be 4. That works. Oh, that's Y. See, you need to be really careful. Let me get my rubber. We said here that Y was 8 because 2 8s are 16. And then we'd had to add on 4. That works. There are more answers. Y could have been 9. 2 times 9 is 18, and X could be 2. So sometimes in these papers, there's more than one answer. You just need to make sure the one you put is correct. So let's just double check it works. 2y, 2 times 8 is 16, plus 4 is 20. Yes, we get a mark. Take the fractions less than 5/8. Notice the denominator are all different in these questions. What I would do is make the denominators the same. So 1/2 is the same as 4/8. Now I can compare them. Is this less than 5/8? Quite clearly. 4/8 is less than 5/8. 2/8, yes, that's less than 5/8. 3/4, again, make this out of 8. So we're going to do 4 times 2, do the same to the top. 6/8, that is not less than 5/8. Leave it blank. 7/16, well, for this one, I'm actually going to change my question 5/8 into 16ths. So I'm going to double it. I get 10/16. Is 7/16 less than 10/16? Yes, it is. And here's 32. My goodness. So again, I'm going to change the fraction in my question. 8 to 32 is times by 4. Do the same to the top. 20 out of 32. Is 24 out of 32 less than 20 out of 32? No. So number one tip here, before you compare fractions, make the denominators the same. That's really, really key in my opinion. Question 19. I did this in a 3-mark question video that I did recently. So let's take a look. Layla makes jewelry to sell at a school fair. Each bracelet has 53 beads and she makes 68 bracelets. So what it's testing here is, do you know that we have 68 bracelets and on each one is 53, so we have to multiply. That's how we get the amount of beads on the bracelet. Necklace has 105 beads. Okay, I'm going to have to multiply that by 34 necklaces. So these are the two things we've got to do, because the question is saying how many beads are used altogether. So 68 times 53, this is a 3-mark question, because for this one, if you show me you can do this, it will give you some marks. Okay, you don't need to do the full question to get marks on this one. So 68 times 53, 68 times 53, I've done this a million times, but it's always good to do practice, isn't it? Long multiplication, we're going to times by 3 on the top row, and we're going to times by 50 on the bottom row. 3 times 8 is 24, exchange over a 2. 3 times 6 is 18, add the 2, it's going to get me 204. 50, now I need to put a placeholder in. Now I can do multiplying by 5. 5 8 to 40, exchange over the 4. 6 times 5 is 30. Remember, I've still got that 4, so it's 3,400. We put a 4, a 0, a 6, a 3. Okay, that's how many beads were used to make the bracelets. Now I need to do 105 times 34. 105 multiplied by 34. Cool. Again, I'm going to do times by 4 and times by 30 just to make sure. 4 5s are 20. 4 times 0 is nothing, so the 2 goes straight in. 4 goes straight up, 420. 3 here, it's not actually 3, it's 30. So I put a placeholder in. Now I can do 3 times 5 is 15. Go straight in because the next one's 0. 3 times 1 is 3. And we're going to add these up. We get 7 in the tens, 5 in the hundreds, 3 in the thousands. So we have 3604 and 3570. How many beads to use all together? Final step here. Let's add them up. 3604 plus 3570. We end up with 4 in the ones column. Put that in. We end up with 7 in the tens column. Put it in. 11 in the tens column. In the hundreds column, sorry. Put a 1 in. 3 plus 3 plus 1 is 7. We have 7,174 beads. Simple as that, guys. Hopefully that's not too tricky, and if it is, we need to practice your long division, long multiplication. We've got videos on that on the channel. Go and find it. Adam is making booklets. What a fun job to make booklets, eh? Adam's making booklets. Each booklet must have 34 sheets of paper. He has 2 packets of paper, and there are 500 sheets in each packet. So firstly, straight away, we know he's actually got 1,000 sheets of paper altogether. How many complete booklets can Adam make from 2 packets of paper? Okay, well, 34 is one booklet. So what we can do here is we can do a long division, because we have 1,000 pieces of paper, and I want to know how many times 34 can fit inside. So again, we can make our toolbox. Hayden's released a video, or is releasing a video, might be out by now, all about long division. So if you're stuck on that, go and watch it. 134 is 34. 2 34s are 68. 3 34s are 102. Okay, so I'm just adding 34 each time to make sure I get the right answer. So 34s into 10. 1, sorry, don't go. 10, don't go. No, I didn't go. We're going to do 100. I'm losing my voice. I've done so much maths in this video. So that's going to be 2 lots, which is 68. And then we have to do a subtraction to see what's left over. 100 take away 68. Well, that's going to get me 32. And then I'm going to bring down this 0. So how many 34s can I fit into 320? Here's where we have a shortcut. 10 lots of 34 is 340. So 9 lots of 34, that's too much, isn't it? 9 lots of 34, I'm going to take away 34 from 10 lots. So I'm going to end up here with 306. 9 lots of 34 is 306. If you don't believe me, you can do 9 times 34, see what you get. But it does work. So that means 306, which means I get 9 booklets, uses 306 bits of paper, and there's going to be 14 bits of paper left over. That's not enough to make a whole booklet. So the answer to this question is 29, because that means I can make 29 whole booklets. There are 29 34s in 1,000 with 14 pieces of paper left over. That's not enough to make a booklet. You get 2 marks for answering that question. A, B, D, E is a rectangle on coordinate axis. I've covered this before. I've done lots of tricky questions. Let's see what we can do. The sides of the rectangle are parallel to the axes. Point C is the center of the rectangle. What are the coordinates of B and D? Well, how do we work this one out? Well, we need to know that C is the midpoint. That's really important. So let's think about B for a minute. This one here. Okay. So this is 25, 30, which means we go 25 across and we go 30 up, which means I can label 30 here. What's really cool is that means I already know the Y point for B. So it must still be 30 because it's 30 tall. So B, I'm going to put 30 tall. How can I figure out how far across B is? Well, I can, because look, C is in the middle. So I can mark here 40 across, which is the first number. So we go from 25 for the first number, which is A. 40 across is halfway. So all I need to do is whatever this jump is from 25 to 40, do it again, because I know 40 is halfway. 25 to 40 is 15, so we add another 15, and we know that this is 55 across. So B is 55 across and 30 up. Now we need to do D. Well, look, D's right here. So this is quite cool. We already know it's 55 across. We've worked that out. How far up is D? Well, let's use the same logic. C is the midpoint. So if this is 30 high for Y, which is here, 22 high is going to be the halfway point. Well, how can I get to this one? Well, if 22 is halfway, whatever the jump from 30 to 22 is, I need to do that jump again. That's a jump of -8. So I'm going to take away 8 again, and I end up here, if I take away 8, with 14. Okay, so that means I know it's 14 high. So D is 55, 14. It's as simple as that. The great thing about B and D, look, they're on the same X point. So once we worked out X, we're done. We just need to work out Y. Really, really love that question. It's about knowing C is halfway. And if you're given halfway point and you know the point here, you should be able to work out the point on the other side. It's the exact same jump. Okay. 22. I think this is the last question. No, it's not. We've got one more. Midpoint. That's a really good one. So 2 more questions, guys. Stick around. Make sure you like the video. It's really hotting up now. So these ones are really tricky. See what you can do. 6 identical right angle triangles are arranged to make a rectangle. I love this question. Calculate the length of the rectangle. How on earth can we work out this length? Well, we need to know this side of a triangle. So this long side up here. How can we work that out? Plus the width of a triangle. How can we do that? Well, the only thing we're given is that this is 7 centimeters. What do we know about this height? Well, firstly, it is 2 lots of this short side here. So to work out one of them, I'm going to do 7 divided by 2. It must be 3.5. 3.5, 3.5. So the cool thing now, I can put 3.5 as this length. All I need to do is work out the height of a rectangle, this long one here. Well, guess what? Because these rectangles are identical, this length here is the same as this length here. And what do I know about this length? It's 7, because the height is the exact same. So I can put 7 here. So I know this length is 7. This is half of that because I have 2 3.5s. 7 plus 3.5. The length of that rectangle must be 10.5 by combining these 2 lengths. Love that question. Did you manage to get that? Let me know in the comments down below. Question 23. Ooh, okay. The distance from point P to R is 800 meters. So here to here, I'm just going to label it. This is always good practice, is 800 meters. The distance from P to Q is 4 times the distance of Q to R. So what we've got here is Q to R, and then I've got 4 times that. 1, 2, 3, 4. So you can see P to Q is 4 times R. It's not exact, it's not to scale, but it's got a real rough idea. Olivia says it is 600 meters from point P to Q. Explain why she is not correct. Well, why is she not correct? What is the distance from P to Q? Now here is where I want you to put your answer in the comments. And I'm going to pin someone who gets the answer right. Why is Olivia wrong? And what I want you to do is prove to me why she's wrong by using some working out. What is the actual distance from P to Q? And then you need to explain it. How did you get there? What might have Olivia done wrong? What did you do to get to the right answer? If this is 4 times the distance from Q to R, what is this distance from P to Q? Tricky question. You're going to let me know in the comments, guys. Hope you enjoyed this video. You're going to give me a like. You're going to give me a subscribe. And if you're really stuck, put down in the comments, I don't know, and I will help you out. I'll reply to a couple, okay? Guys, I'll see you next time. Hopefully that really helped you. We've got loads more videos on the way. Make sure you subscribe and see you next time.